So first of all, point out that I think you all know, because it's in the invite and it's in my post on LinkedIn, I will be recording this presentation, this session, and you can send this to that by joining us and by being here. I think all of you have already done it, but mute your microphones if you don't mind. And I prefer to keep questions to the end. If there's really something pressing that you can't wait till the end for, then of course stick your hand up or say something, but hopefully it's all fairly clear, and then we'll have plenty of time at the end of the presentation to have a bit of a discussion. So introduce myself, and then I've also got Mike online here, Mike Blundell. We're doing this course between the two of us. I have been in the automotive industry for 35 years. I've worked full-time, nearly full-time, the last couple of years was part-time, for Jaguar Land Rover, initially just Land Rover, and as part of the Rover group, and that became Jaguar Land Rover in the early 2000s. Worked on various different things, initially ABS and traction systems, and then we started inventing other systems like hill descent control and terrain response. I became a technical specialist in about late 2005, initially for off-road capability, and then I moved into the area of tyre testing, in particular tyre modelling, tyre CAE, as we used to call it in JLR, and I became a technical specialist for that. And when I joined, there was one guy already there, and I was the second, and I took the lead, and I built and recruited what became the Jaguar Land Rover tyre CAE team. One of the first things I did, of course, was devise a strategy, and then over time we executed that. And then I finished at Jaguar Land Rover because an offer was put out late July last year for voluntary redundancy, and for people like myself that was quite attractive. But I'm a bit too young to stick my feet up and go and play golf, if I had ever done that before, or go play more tennis, which I do. So I'm now working under the umbrella of JP76 Solutions, and I want to still work in the same area that I enjoyed working in the last 12, 13 years. A few things already confirmed. I had my first column in UK media, Tyre Tech magazine, and we are going to be doing lectures, training courses on the topic of tyre modelling, and I might also be doing some on sort of the history of Land Rover. The training course that this is basically a promotion for, a taster for, is going to be delivered by myself and Mike. And as I say, as part of the JP76 Solutions, well, company is a big word. It's a sole trader, initially set up based in the UK, basically working from home. I've got no permanent employees, but working closely with Mike, already mentioned, and yeah, hoping to be consulting, presenting. I've already done a presentation last November at a conference, doing columns and the training course that this today is all about. And we were doing the training courses in conjunction with Mike Blundell, who's here as well and can just briefly introduce himself, if he doesn't mind. Is that okay, Mike? Maybe Mike wasn't expecting this. Well, Mike's looking for the mute button. Can someone? Mike hasn't got sound. I need to admit him back in. Okay, hope you're there, Mike. Otherwise, I'll do it. So Mike's got 45 years of experience in the automotive industry, and particularly in academia, working at Coventry University. He started off working with Boeing and TDS, but has been at Coventry University since the early 90s. Became head of department, associate dean even for a few years, and is now professor for Vigor Dynamics and a few other things. And if Mike joins us, then he'll be able to be able to say what those things are. And he was also a visiting professor in the US, at Purdue, at Windsor in Canada, and in Bergamo in Italy.
Well, just to let you know, I'm back in the call, Jan.
Hey, okay, so you can take over then, Mike. Did I miss anything?
No, I don't think so. I think you've got the main areas there: vehicle dynamics, a lot of safety work recently, and tyre modelling where we've collaborated.
And you got some specific interests.
Yeah. I've done a patented invention to prevent aquaplaning. We call it the run dry tyre system. It's not the only type of system like that in the world, but the idea is to use a pressurized gas in front of the tyre to give you a temporary dry contact patch. So we're looking at developing some research to take that forward at the moment.
Yeah, and if anyone is interested in knowing more about that, then I'm sure Mike will be more than happy to talk more about that.
Sure.
Great. Okay, thanks, Mike. I'll move on to the next slide if I can. Yeah, here we go. So we've done the introductions, and then for the rest of the sessions, we'll run through these following points. But the main purpose, as I think I already mentioned, is to introduce you to the topic of tyres, tyre testing, and in particular tyre modelling, and to whet your appetite for more, basically, and in particular the one-day training course, which we still have a few spaces for. It'll be run on the 10th of February, but I got a few more details on that on the next slide. So it'll be on the 10th of February, hosted by IPG Automotive in Solihull in the West Midlands. Happens to be just around the corner from me, but it's basically very convenient. Midlands, middle of the country, near motorway junction number 4 of the M42. It's at the Blythe Valley Business Park, and it's a nice, very nice conference room. I posted a picture of that already on LinkedIn, if you may have seen that. And as a bonus of doing it at IPG, in the lunch break or other breaks between each session, there will be access to IPG's static driver simulator. It is only static, it doesn't move around, but it's still very realistic, and it's still very worthwhile to have a go in that, and you will be able to do that if you join us on the course. We are definitely going ahead with it, but we do have space for a few more candidates, and hence this promotion activity, of course. So topics we'll be talking about: introduction to vehicle and tyre development, vehicle dynamics of the role of tyres, tyre development. You can read what's on the screen there, of course. Then the next slide, we've got the timetable, and although there's some nominal presenter names down against each session, we will be pitching into each other's presentations as well. It's going to be fairly flexible, and if we feel we can contribute an interesting point to each other's presentation, then of course we will not hesitate to do that. And Mike and I will also be more than open to continue discussions afterwards when the course finishes. Due to where we are, we need to be out quite sharply at the end of the day, but there is a pub nearby that's been recommended, and we can go there if people that are on the course are interested in that. Okay, so just to give you a taste then of tyre modelling, hoping to point out that that is not trivial. Our one-day course will be able to give you a flavour, but if you really want to know more about it, then we'll be looking at a multi-day course, which we would also be more than happy to lay on for you. When we did this when I was doing this sort of events training courses in JLR, we actually used 5 days with different themes per day. So to condense that into one day has been quite tricky. 6 one-hour sessions. It will give you a flavour, but to go into details, we'd have to set up some follow-on sessions. So yeah, computer-aided engineering, CAE, virtual development, simulations, using models, all those good things. It's basically trying to go from driving test cars to doing things in simulation, whatever your simulation package of choice might be. Simpac, Adams, CarMaker, VI Grade, to name but a few. And the modelling then can feed into the development work and to an extent replace that, but of course the modelling should not be an end to itself. Sometimes it can be quite difficult to get data to support modeling as well. Some people might come up with the expression that's quite in vogue at the moment, digital twin. And that is basically trying to replicate your real physical property with a simulation model. In my mind, it's kind of doing things, it's still creating a physical property first, usually, and then trying to replicate it as a model, when really what we want to do is doing CAE, doing models first, having confidence in those models, and only then create a physical property to sign off basically everything we've done in the simulation. And we want to do that because physical tests are much more expensive. CAE is much cheaper. We will not need prototypes to be shipped all over the world. That costs a lot of money, and also it basically you build a very expensive prototype and then you stick it in you're sticking it in customs, you're sticking it on a plane for several days, you're stuck in a harbour somewhere. All those things is not ideal, and also physical testing is not particularly repeatable and reproducible, which CAE is. And if you want to do simulations of how vehicles behave dynamically, then of course tyres play a very important role in that. And if you want to do simulations of dynamic behavior, then of course you will need tyre models. And they are then used to do development of vehicle dynamics, attributes, durability, reliability, or dependability, as some people call it these days, NVH, noise, vibration, and harshness. And just more specialist areas such as the steering teams, the wheels and tyre teams, etc. I'm not going to go into detail on this, but tyres do their stuff by virtue of friction, by virtue of grip between the tyre and the ground. There is no grip without slip, so you always have to generate a little bit of slip to generate the forces, either be they lateral or be they longitudinal, i.e. fore aft or left to right. There'll be a lot more about that on the course, but even there we will barely be able to scratch the surface, pun intended, as it's a complicated topic, and there's a lot of research going on in this area, and you probably need several areas to really dive into the depth of it. My next slide is a bit more about just to introduce the certain terminologies I already just mentioned: lateral and longitudinal. So longitudinal being fore aft, lateral being side to side. But there's also terms such as camber, inclination angle, so how much the wheel tilts, slip angle, how much the tyre is pointing away from the straight ahead. And there'll be much more about this on the course, of course. And a friend of mine in the industry, Dr. Christian Bachmann from FK in Germany, was recently quoted in Tyre Tech magazine, and he was saying, "Tyres combine mechanical complexity with highly non-linear behavior." And basically, I couldn't have said that better. Tyres are complicated, but it also makes them very interesting to work with. Again, I'm not going to dwell on these various graphs, but these are various typical graphs that you can produce if you test tyres and then plot the results that you get. So these are typical ways of looking at the data you might gather for a particular tyre, or more often than not on several tyres, and you want to compare those to each other. And the tyre modeling is then about coming up with mathematical equations that, for the same input conditions as you had on your rig, produce the same forces and moments as you measured on the rig. That's probably the shortest I can put the principles of tyre modeling. And for magic formula models, which we will talk about a lot more on the course as well, the magic about that particular tyre model is that someone came up with some equations and they magically match the shapes of these various curves that you typically measure on a tyre. For other models, the principle is still the same, but those types of models, such as F-Tyre and CD Tyre, are models with physical properties such as stiffness, damping, grip, etc. But again, the principle is the same. You have a model, you give it the same conditions as in your measurements. Your model then predicts some outputs, and you compare those with what you've measured, and you keep tweaking the parameters in your model until your model matches what you've measured as closely as you can get it. And depending on what model you have, that can take a matter of hours, days, or even weeks. So yeah, almost all tyre models are based on test data. Many different types of tests are used. In the ideal world, you would try and avoid doing physical tests. You would do virtual tests. You do finite element analysis. But most of the time, you are still looking at physical tests. So that could be a flat track, like on the top right here, or it could be outdoor on what's pictured here is of VBOT, the Jaguar Land Rover test vehicle. Tests can be static or dynamic. So a static tyre is literally what it is. It's not rotating. It's just pushed down or pushed sideways or steered. You can have curved surfaces or flat surfaces. You can be looking at lots of different aspects of the tyre with regards to performance, durability, or performance versus any tyre perfections, or more likely than not imperfections, or how a tyre wears, etc. These are just some of the models, some of the types of models, and where you might be looking to use them. And as you can see, there is some white space in this graph as well. So in that case, you might struggle to do simulations of those kinds of load cases, those kind of maneuvers, with the models currently available. So yeah, there is still some model development potentially required to try and fill that white space. But typically, empirical models would be looking at something like magic formula. Physical models would be looking at things like F-Tyre and CD Tyre. And for FE models, we'll be looking at Abacus or similar types of FE models for tyres. We would not normally use those in the sort of dynamic simulations, dynamic work that we typically are talking about here. So again, I put this on LinkedIn to try and prompt a bit of debate and sort of try people to get people's attention, basically. But the current process, as I've just described it, is very much you make a tyre, you test it, you get some data, you create a model, and then you can do your simulations. But that's not ideal, because you'll be already making a tyre, which costs money and time, and it might not be the tyre that you need. So really, the design process is creating a models first of a tyre. You have to, of course, be confident that you can make that tyre. But if that is the case, then really you want to do your your selection of how the tyre should work and what it should do and how it should behave and everything else iteratively in CAE by using simulations, and only make the tyre once you are happy that it works with your vehicle model, it works with your vehicle design and all the other properties. And in this particular graph, I've put SimPack and IPG, but as I've already said, also on LinkedIn and earlier, other simulation packages are available, VI Grade, Adams, and others. And really, you want to optimize the tyres in the CAE and only then produce them. And really, you should try and get to the point where you can print a tyre. But that process relies on two key capabilities that you need, two key things. You need capability, you need accurate CAE, you need accurate simulations, both for the tyre and for the rest of the vehicle, of course. And you need objective targets. Because if you want to do your development and your attribute training virtually, then you need to be able to do that offline. Perhaps even doing some automated varying of various components and then work out which one gives you the best performance. Well, in that case, you need objective targets for that performance that you're interested in, unless you want to go to using driver simulators, but then you're putting the human back in the loop, and then you're getting the problem again of repeatability and reproducibility, different drivers giving different results, different drivers using different methods, and even the same driver perhaps not being always consistent. So you really need to do things as objectively as possible. And that needs objective targets developing for a lot of things where there currently are no objective targets for, at least not in the company I've worked for. So the vision that I have and been advocating already in my previous job, but even still now when I get to advise people on how to do tyre modelling and how to go about it, you should really aim for having virtual tests for every physical test that you do in your vehicle development and your component development. You know, to sign a vehicle off, to sign components off, there is an enormous amount of physical testing done on test rigs, on the roads, on test tracks, in labs, whatever. And ideally, you want to take stock of what all those tests are and see if you can develop virtual tests to replace those physical tests. And then you can do your vehicle development and your attribute balancing virtually. You can do your sign-off virtually. And ideally, you wouldn't produce any physical prototypes till really, really much later in the vehicle program than is currently being done. And most people, when you get to that point, would not be able to tell that that physical prototype late in the program isn't quite there yet. Probably only very susceptible, very critical people will be able to tell that there's still a few percent to be gained by some tunable components or software parameters on the vehicle to get to the 100%. But you will be more or less nearly there. And I know that this vision is not realistic yet, but you need to have something to aim for. And really, the physical prototypes that you do eventually build should just be used to confirm what you've done. And you should try and get to this stream of events, basically, where you have your targets, your DNA, what you're aiming for to develop for a particular vehicle. You do your simulation work. If possible, you'd also go to the driver simulator. Then you make tires, you make prototype vehicles, and then you go into production with your final configuration of everything that you were able to tune. So in a summary, this is a little bit of a dry slide, but it's important to include it because it's the foundation of the course that we are offering. It's very much an introduction to the topic of tyre modelling and tyre testing that is often required, and just how tyres work, so the basics of tyres. It's suitable for anyone, engineers, managers, students, anyone interested in the topic is welcome to join us. As I already said, it's an extract of a 5-day course as we used to run it previously between Mike and myself. And if more than a 1-day course is of interest to you, then please get in touch. Or if you can't spare the time for a whole day to learn about tyre modelling and you want something even more succinct, then we can also be looking to develop that. And as already mentioned, there are some places left. So just a couple of slides then to summarize the exact offer of the course as it is planned for the 10th of February. 10th of February, IPG UK in Solihull in West Midlands in the UK. Very convenient in a sense that it's essentially in the country. It's not far from Birmingham Airport. It is very close to a motorway junction, junction number 4 of the M42 motorway. The price is still reduced at the special offer price of £340. We were planning to ask for 400 for people that were joining us at the last minute, but we'll stick with 340 if people are still interested to join us in the next few weeks. We also have introduced a student rate and already mentioned that it's 6 1-hour sessions and that snacks and lunch and refreshments are included. If you are interested, drop us an email or fill in the form on this link or scan the QR code. And the slides of the presentations, the 6 1 hour sessions adds up to about 250 slides. They will be made available as a PDF, but for personal use only as much as possible. Future plans, we can of course run this course again now that we've got all the material ready or nearly ready. So there will be future dates and locations, might be elsewhere in the UK. We more than likely will try and increase the price because, you know, once we've perfected it after the first running, we can also do bespoke courses, either shorter, try and summarize things even more, or longer, like I already said earlier. We can deliver them in person anywhere in the UK, Europe, or even further afield. Although further afield probably would become a little bit expensive, so we could look into doing that online. But in that case, I would probably still be looking to do that classroom-based, where a trusted colleague that I know in that particular country can facilitate and can manage that course for us remotely, and Mike and I will just dial in and present like I'm doing tonight here now. And that is basically it. So I don't think we've got all that many attendees tonight, but if any of you do have any questions, please do not hesitate to ask. Don't all shout at once.
Yeah, hello. Just a little bit of a brief introduction as well. I am studying at Coventry University. I am an undergraduate student. I did my placement at Pirelli as a R&D as a R&D process student. So it's very interesting to obviously see this, and I kind of know a little bit of ins and outs as you were speaking of going through numerous loops, to say the least, to actually get a Tyre to where it should be and actually going on those Bentleys, etc. I'm kind of pursuing this within my bachelor's degree currently, as I am a motorsport student and we don't have a lot of equipment such as TPMS sensors or any tyre testing machinery. I was wondering if you had any advice as to what I should possibly look into investigating within my dissertation, let's put it this way. I was wondering if you had any ideas possibly.
Not right now here off the cuff, but we could maybe have a chat some other time in the next few days or weeks.
I could probably pitch in a bit here, Jan.
Oh, go for it, Mike. Yes, of course.
Yeah,
you are at university anyway.
Henrik, did you say you're at Coventry University?
Yeah, yes, correct. Under Richard Nicholson.
Oh, yeah, I know Richard very well. Well, I'm in one of the research groups at Coventry University, Future Transport and Cities. What are you in your final year now, looking for a project, are you?
Well, I kind of have a project. It is tyre modeling for former student deployment, which essentially means I'm trying to optimize the tyres as much as I can, what pressures, what lateral G we can get out of them, and essentially making them work on track without any heat and blankets, and just essentially getting the setup ready for competition. And yeah, that's what kind of my final year project is about. Yeah. I was supposed to have some funding for TPMS sensors, which would have been absolutely fantastic. But the way things are looking currently, it's not going to be available. So solely I'm relying on previous telemetry data that we have from the car to see if we can build a tyre model from it, essentially. And that will be my final project of the year.
Okay. Yeah, it's always a challenge, particularly in the timescales for a student project. So I think doing any testing is not feasible, but certainly you'll find me on the email system at Coventry University. If you want to consult me, ask me any questions, please do.
Perfect. Thank you so much. And I'll definitely send an email through. I do have a fantastic supervisor, Gary Wood. I'm not sure if you do know him.
I was Gary Wood's PhD supervisor.
Oh, fantastic. Then I'll definitely shoot yourself an email as well, and I'll be in touch.
Yeah, very good, Henrik. It'd be good to hear from you.
Perfect, thank you.
Please join us on the course if you can.
Yeah, I will. I'm hoping to do so at some point down the line. Still kind of trying to immerse myself and understand the tires, but if I'm completely honest, the more I seem to understand, the less I seem to understand in a way as well.
Yeah.
That's the most healthy thing anyone could say about working with tyres, Henrik.
I don't know whose quote it is, but I saw it once, at the end of a book kind of thing, and it basically said, "Yeah, we are still confused, but at a higher level."
Exactly. So, it's fantastic to see this presentation. I really enjoyed it, and hopefully meet further down the line as well.
Great, lovely. Anyone else?
Yes. Hello. Good evening, Mike and Jan, and everyone present. A little introduction about myself. My name is Ativ. I recently completed my master's from Cranfield University. I had a question in terms of developing more tire models and understanding more about them. Again, someone not having a lot of resources, when you have to practice tire models, when you don't have the data available, is there a possibility in exercises in which you have data sets available that you can practice the magic formula on? Or if are there other tire models apart from the magic formula that someone can look and explore and try to build knowledge about it?
Yeah, well, two things I'd like to point out. One is that I do plan and hope, it's not confirmed yet, but I'm hoping that we can offer people that go on the course a trial license of a software called Optimum Tyre that allows you to create metric formula tire models should you have tire data. But at the very least, it will allow you to look at tire models using that software, and will give you, I think, about 3 different tire models of quite different tires, and you can compare them. We'll ask you some questions about them. You can have a look in the Optimum Tyre software and see if you can answer those questions. And then as part of the surface, we will look at, any results you come up with. So that's one thing. So I hope that's not 100% confirmed, although I'm pretty confident that we'll be able to do that. That's one thing. If you don't have access to test rigs such as a Calspan or other test rigs that really give you the proper data to create tire models, then it is worth looking into an approach that was developed as a part of a PhD project sponsored by Jaguar Land Rover by this lady at the bottom here, Dr. Agata Utana. I think Mike set in on her PhD, or was that Megan's? I'm not sure. Anyway, she worked for me in Jaguar Land Rover and is still there. I can put you in touch. I don't know how much of the project is public and how much is confidential to Jaguar Land Rover, but she developed an approach that was based on basically taking some very basic measurement of the tire dimensions and almost not a lot more than that, and that in combination with a brush model that she had developed, a brush type tire model that she had developed, allowed you to get fairly close to a metric formula tire model as you would get it from putting it on a Calspan rig. Of course, not nowhere near exactly the same, but still to a useful level. So, all models are wrong and some are useful, and it was still producing useful models. So that is an approach you could potentially look into taking, depending on how much of that is public.
Understood. Thank you so much.
You're welcome.
Hi, Jan.
Hi, Dan.
Hi, and hello, Mike. Nice to meet you.
Hello, Dan.
Jan, we have been connected since a while on LinkedIn, and we got the chance to meet several times at Tyre Technology Expo. And I kind of agree with your I agree pretty much with your ideas and your vision of having processes and development tools, methodologies to reduce, the physical testing in general. We spoke about this a while ago.
Yeah.
First question is, do you really think that there is a market for these courses, for this type of education? I mean, to scale it, to have engineers properly prepared for the actual work and the actual vision that you are saying.
Yeah, I'm quite hopeful. Obviously, we've had some people already on the course register, and we will be going ahead. Therefore, I've also had quite a lot of interest from people that aren't able to make the session on the 10th of Feb, but are nevertheless interested. They can't make it because they're busy, or they can't make it because they're in other countries. So we are already investigating potentially doing this training also in Germany, for example. We've also got some feelers out with Italy, and I've got a discussion on Monday. Mike doesn't even know this yet, but I'm speaking to someone in India potentially doing the course as well. And I've definitely already had, when I was pitching this from sort of October last year, I've had a lot of interest from people in India. So if we can somehow do it for them, I think that would be quite good.
When you say interest, you mean students or master degrees, and also employees or engineers from companies like tire makers or OEMs?
A bit of everything. There was even some people from IPG, but based in India. There were students. There were tire company people. Yeah, all sorts.
Okay, and I don't want to monopolize the discussion.
Yeah.
One more question I want to ask you: do you have any part of like hands-on part in which students can do actually something on their own with some models, some types of models?
Yes.
And if you allow me, I put it in a context why I'm asking this, because I assume some of these tools need licenses and infrastructure and so on.
Yeah.
Data.
Yeah. So as part of when we were in this course in Jaguar Land Rover, there was always a bit of homework, and I'm hoping to do something similar. So I'm hoping to give people a few tire models, metric formula tire models, to have a play with, have a look at, compare to each other, and try and draw some conclusions from. Now, to do that, they will need some software, and I'm hoping to do a deal with Optimum G, with Claude Ruel from Optimum G. And I've asked him if he would be happy for people to have a trial license of his Optimum Tyre software, so that people can do this homework. And I'm fairly hopeful that it will be possible, because if you go on the website for Optimum G, and that you can ask for a trial license on Optimum Tyre. But I'm hoping to officially agree that with Claude.
Okay. Good. That's it for the moment. In any case, I'm also kind of in the same business, trying to do something, but more on the FEA side,
Yeah.
Specialized on smart tires.
Courses.
And I'm also trying to, find the best way to provide the best quality in terms of information, data, and so on. But sometimes I find this difficult. That's why I ask you this, because I find these limitations from people not having actual access to work with the models, to apply, to have hands-on sometimes, and that's difficult if you don't. If you cannot offer, or if the student doesn't have access to the tools to apply also,
Yeah.
But we can always follow up on this at any time now.
Yeah, more than happy to. Great. Thanks, Dan.
Yeah.
Anyone else got any questions about the course, about the topics I mentioned, gave a flavor of? No? Don't be shy. If you think of something afterwards, then of course feel free to email me as well. And I will be running this presentation again tonight, 7 o'clock UK time, for people that couldn't make it today and would still like to see us live, because obviously the video will be made available anyway. So yeah, you can always come back tonight, listen to it again, and ask me some questions if you thought of them in this afternoon. Is there anything you'd like to add, Mike, whilst we've got you here as well?
No, I think you've covered it well, Jan. And I think the main thing is it is a challenge to take all that material from a 5-day course and put it into a 1-day course. And I think you've managed that quite well. And I think it really would be very useful for people who are new to the subject, whether they're a student starting a PhD in the area, or they're moving into a new post in a company or joining a company where they need to know something about this.
Yeah, thank you, Mike. Okay, in that case, I think we should wrap it up. Yes, going once, going twice. Everyone happy for us to end this?
Yeah.
Hello, just one question, quickly, just one question. Karan here from Dufonia Industry, technologist, tire modeling engineer. So I have a question, and I completely agree with Mr. Dan. So for example, the Pasishka model, it's kind of open source model, we can say. Anyone can develop as a student, with the basic or empirical formulas. But when we talk about the CD Tyre, F Tyre, which is kind of a product from the company, and if some students want to learn at the very young age, they cannot have the access because it's quite expensive in terms of licensing, and so are these models are covered in this upcoming yours presentations or the seminars and everything?
Yes, definitely. We talk about both F Tyre. Well, the 3 main models we talk about are Magic Formula, F Tyre, and CD Tyre, and we've got some various slides on each, and the pros and cons for each, and also the current status on those different models, and how they are used and what they're used for, and they're good points and they're less good points.
Yeah, I think I'd just qualify that as well, Karan. It's not the intention of the course to train you in the use of any one of these softwares, but really to make you understand what these different softwares do and how they're used, and what the aspects of like the sort of testing you need to do to get the parameters to populate the models. But not, it's not, you won't come out of the course and know how to run CD Tyre, for example, but you'll know what it does.
To learn how to build a Magic Formula model, you can learn that in a few days. To learn how to fit an F-Tyre model, you're looking at several weeks. To learn how to build a CD Tyre model, you're looking at 2 or 3 months.
Yeah, completely.
That's basically the scale of things.
Yeah.
Okay.
Thank you, Mr.
You're very welcome. Is that going to be it? Or anything else last minute? Okay, well, either join us tonight or drop me an email if you do think of anything. But thanks very much, everyone, for attending and for allowing us to video this for anyone else that couldn't make it. Cheers all. Have a good afternoon.
Thank you. Cheers. Bye-bye.
Bye.